Hello everyone, welcome to my channel Chemical Engineering Knowledge. In this lecture we will discuss about the transient heat conduction in large plane wall, in cylindrical object and in spherical object. Remember, in this lecture we will discuss the heat transfer only in one direction. So in this lecture we will discuss the transient heat conduction, large plane wall, long cylinder, and in spherical objects. In this lecture we will discuss the transient heat conduction in large plane wall, the heat conduction in long cylinder, and the heat conduction in the spherical object. So we have already discussed the transient heat conduction. In transient heat conduction the temperature changes with the passage of time, and in lump system the temperature was considered to be constant at every point. In the lump system the temperature at every point in the object was considered to be same, and the temperature difference was 0. The Bennett number for lump system was 0, but in reality there is a small temperature difference. At different point temperature difference can be slightly different. So the temperature at this point can be different from the temperature at this point. Similarly, the temperature from this point can be different from temperature at this point. So there is a slight difference in the temperature in the object. So in reality no system is lump system. So there is slightly differences in temperature at different position in the object. So in the reality the temperature is slightly different at every point. Now we know that, suppose what will be the transient heat conduction in a large plane wall. First of all we will study the transient heat conduction in a large plane wall. Suppose this is a large plane wall. This is a large plane wall. This is the thickness of the wall. Suppose this is the origin. This is the thickness. This is the thickness at the right hand side. The thickness is x. Similarly, the thickness at the left hand side is also x. It is also x. So this is also x, and the total thickness of this wall is 2x. X plus x is equal to 2x. The total thickness of the wall is 2x. This is the length of the wall. This is the plane. This is the plane wall. So how the temperature will changes in this plane wall. This was the plane wall. So the plane wall, this is x, this is also x. My drawing is not very good, but this is x, and this is also x, and this is the 2x. Now this suppose this plane wall, this is the plane wall. This plane wall is placed in a fluid. This is a fluid. This is air or water or some other medium. Suppose the plane wall is placed in fluid having temperature T infinity. The transfer coefficient of the fluid is H. The temperature in the wall is, suppose it is T. temperature of the wall is T. This is the center of the wall. This is the center of the wall. Suppose the temperature of the air or the medium is small, then the temperature of the wall. This is the hot wall. So the heat will transfer from the wall to the fluid. Heat will transfer from the wall to the fluid. The heat will first transfer from the surface of the wall to the fluid. As the heat transfer from wall to the fluid, at this place the temperature will be small. So the heat will transfer from this position to this position. As the heat transfer from this position, the temperature at this point will be small. So the heat will transfer from this point. So the temperature at this point will be decreased. So similarly, the heat, first of all, the heat transfer from this end of the wall to the fluid. So temperature at this point decreases. As temperature at this point decreases, so the heat will transfer from this position to this position. As the temperature at this point decreases, so the temperature will transfer from this point to this point. So the temperature at this point will be decreased. So the heat will transfer from this position. So the heat transfer from the center of the wall to the sides of the wall, and from the sides of the wall to the fluid in which the wall is placed. So the temperature at the center of the wall is Ti, which is initial temperature. Suppose at time t is equal to 0, the temperature at the center of the wall is Ti. Now we place the wall in a fluid, then the temperature in the wall will decrease. So the heat will transfer from the sides of the wall to the fluid. As the heat transfer from the sides of the wall to the fluid, the temperature at these position will be decreased. So as the temperature at these position decreases, the heat will transfer from the center to the sides of the wall, and finally the temperature in the middle point will also decreased. So in this case the heat will transfer in both directions. So the heat will transfer in this way and also in this way. So graphically we can represent this temperature with the passage of time, also with the passage of x-axis. Suppose this is our plane. So suppose this is a time. Suppose this was a wall, plane wall. This was the center, and this was the T initial temperature. Time t is equal to 0. The heat was transferred from system to the surrounding. Remember, the surrounding is air, or medium in the system is wall. Is the wall. So at time t is equal to 0, suppose this is the time. Remember, time is not negative. Don't consider that time is negative. Time is positive. So this is also a time. So at time t is equal to 0, the temperature in the middle of the wall was very high. So at time, suppose this time t is equal to 0, the temperature in the middle of the wall was Ti. This was Ti. As the time passes, suppose after 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. This 1, 2, 3, 4, 5. 5 hours. 5 hours, 1 hour, 2 hours, 3, 4 and 5 hours. These are time. So at time t is equal to 0, the temperature in the middle of the wall was high. As the time passes, the temperature was decreased. So the temperature decreased with the passage of time in the plane wall. Now the temperature also increases with the x's. Like suppose this is a plane wall. This is the x. This was also x. This was the middle, which was Ti. At time t is equal to 0, the temperature was Ti, and the temperature was decreased with the passage of time when the wall was placed in some medium like air. The temperature at this point, first of all, the temperature at this point decreased, then the temperature at the heat transfer from this point, and similarly the heat transfer from this point. So the temperature was decreased in the x-axis. The temperature was decreased in the x-axis. First of all, the temperature at this point decreased, then the heat transfer from this point, when the temperature at this point decreased, then heat transfer from this point, and so on. Similarly, when the temperature at this point decreased, the heat transfer from this point to this point, and so the temperature at this point decreased. So when the temperature at this point decreased, the heat transfer from this point to this point, and the temperature at this point decreased, and similarly the heat transfer from this point to this point. So the temperature decreased in the x direction, and similarly temperature also decreased with the passage of time. So we can also write the graphical form like, suppose this is x-axis, this is this axis, and this is this x. At time t is at x is equal to 0, at the center of the wall, at x, this is the center of the wall. This is the center of the wall. So at the center of the wall, the temperature is Ti, and the temperature at, first of all, the temperature at x is equal to 0, the temperature is Ti, which is the maximum temperature, and the temperature decreases as we going to right and left from the center. So the temperature decreases. So this is the temperature decreases as we go from center to the right and left side. So the temperature decreases in the x direction, both to the right side and the left side. The temperature decreases. So this is the graphical representation of temperature and the graphical representation of time in the plane wall. So the temperature, suppose this was a plane wall, this was Ti, the temperature was decreasing in the wall. So we can also write that this was the x-axis, temperature was decreased, and suppose if we plot the, suppose this was a plane wall, this is the x, this is also x, this is also x, and this is the center, temperature at the center is Ti, x is equal to 0. So the temperature at the center is maximum and temperature at the side is small, because the heat is transferred from the solid wall to the air, surrounding air, which is the transfer coefficient H, temperature T infinity at both sides of the wall. So suppose this was the time and this was the temperature. In the y-axis there was temperature. So the temperature decreased with passage of time. Suppose 5 hours, time is equal to 5 hours. The time is equal to 5 hours. After 5 hours, suppose after 5 hours the temperature was, suppose after 5 hours the temperature become constant. So suppose at initial Ti was 100 degree, and after 5 hours the temperature reached to 70 degree C. So this temperature is our equilibrium temperature. Now if we decrease the temperature of this air at both sides. Then further the heat will transfer from the wall to the surrounding air. And again, if we plot the graph, then in this case our initial temperature will be 70 degree, and this 70 degree will decrease with the x-axis direction. This will be our initial temperature. 70 degree will be our initial temperature, and it will decrease with the axis and also with the passage of time. Suppose this is the time. This 70 degree will decrease with the passage of time, and suppose after time is equal to 4 hours, the temperature become constant. Then this, suppose after 4 hours the temperature become 40 degree. Then this 40 degree will be our equilibrium temperature. And further, if we plot the graph, then we will use this 40 degree is our initial temperature, and this 40 degree will be decreased with the passage of time. But remember, we will decrease the temperature of the fluid, that heat transfer from the system or wall to the surrounding air. So this is the transient heat conduction in the plane wall. So from these figures we conclude that the temperature decreases, the temperature in the wall decreases with the passage of time, and similarly the temperature of the wall also decreases with the passage of with the x direction. The temperature decreases with the passage of time. This is the temperature, this is the temperature. The temperature decreases with the passage of time. Temperature is a function of time, and the temperature is also a function of x direction. The heat is also transferred from cylindrical material to the air. So suppose this is the cylindrical material. Suppose this is the radius of the cylinder. This is the radius of the cylinder. So the heat will transfer. Suppose this is at higher temperature, the cylinder is at higher temperature, and this is the air. This is the heat transfer coefficient of air. This is temperature T infinity of the air. Similarly, this is also the air. Heat transfer coefficient of the air, T infinity of the air. So the heat will transfer from the cylinder to the air, and the heat will also a function of time. And similarly the heat will also, so the temperature will a function of time, and the temperature will also a function of r direction. In this case the temperature will also decrease with the r direction. Similarly, for spherical objects, suppose if we have a spherical object, suppose this is a spherical object having the radius r. This is the radius of the sphere, this is the radius, this is the radii. Suppose we have a spherical object of radius r. Suppose if we have a spherical object of radius r, suppose this spherical object is placed in air or some medium. So the air, and it is infinity transfer of the air. Suppose there is a hot sphere and temperature T, and the heat will transfer from the sphere to the surrounding, and the temperature in the sphere will decrease with the passage of time, and also with the r direction the temperature will also decreases. And the graphical representation of the heat or temperature in the sphere will be look like this. With the passage of time, the temperature in the sphere will be decreases. It can be form graph like this form, it can be decreased like this form. So it depends on our spherical material, it depends on our temperature, it depends on our the temperature of our surrounding medium, the heat transfer coefficient on the fluid. So these graphs depend on the temperature of the fluid, the material object, etc. So So temperature will decrease with the passage of time. Similarly, the temperature will also decrease with the r direction. With the r direction, which is the radius of the sphere. So the temperature will be decreased like linearly. The temperature can be decreased exponentially, it can be logarithmically, it can be decreased in many ways. So it depends on the spherical object and the temperature of the system, and the temperature of the system, and the temperature of the surrounding. So these are the graphical representation of the transient heat conduction in the spherical object, in the long cylinders, and in the plane walls. Thanks. If you are new to my channel, then please like and subscribe.